the analysis. So NDVI on the infrared image. So we can actually, we can leave that there, but let's turn it off, so to speak. So let's mark that. That's active there. If we look at the instructions, it tells us that we really do need to have this active, and then we can click on the imagery tab, and then we want these raster functions. That will give us this panel here. So that's marked. We click on imagery, click on raster functions, and open raster functions there. And then after a few seconds that opens up. And what we're interested in is NDVI there. Click on that and it asks us for some data. Now what we want is band 1 and band 2 from the NDVI image in order to get this. That would be the ideal solution. So what do we say? We give it the IRF there and it says visible band. Okay, well that was actually, so band 1, well, that's near infrared. So that's not it, so it must be, and then the band 2 was the red. Everything's shifted along, so we take that as 2, and the infrared is band 1. We also want scientific output. This means that it will go from -1 to 1, maintaining the normalized part of normalized difference vegetation index, rather than what happens otherwise is it gives you a fancy output. Do that, and what we'll do is we'll just click on create new layer, and there's an alternative is save as, but let's just click on create new layer, and then we get up this instant answer. If we clicked on save as, there's a whole bit of an interface that we have to go through that isn't entirely evident what means what in it. It's not important really, but then we would save it as a separate file. What this actually is at the moment is just a visualization of this file. We've not saved a new file. The calculation is that quick that it doesn't bother, it's just kept it in the computer memory. So we've done that, and when we look at this, we can see that we've got values from sort of fairly low, nearly -1 up to nearly +1. And we've got the water here with low values because there's not much vegetation, there's not much light in it at all, kind of flat across the board. Slightly more reflection in the visible than the near infrared. But generally speaking, there's not much light coming out of the water. It's kind of dark. And then we have this cyan color matching up fairly nicely with the cyan color in the original image. But then everything else starts to look a bit, doesn't look terribly sort of vegetation-y. So let's just quickly change that. Go to symbology. We can go here and we can do show names on that if you like. And what we want to do is go black and white there. And that gives us a black and white image, which is also fairly useful. It's not terrible. It's not a terrible way to show it, but we can do better. It also seems to be the wrong way around, where we have the lower values are in the white. Despite this, what is it doing? It's supposed to be dark at on the low values and bright on the high values, and yet it's doing it the other way around. We'll work with this. So if we go click on that and we go format color scheme, right? So we want to change this. We want the high values to be green. So let's click on there, and we want it to be leafy green, which I think is that one. And then we're going to keep that as black, and we're going to add a stop in the middle. These are called stops, these little housey things. Let's add one, and it goes in the middle by default at 50%, and we're going to change that to 10% grey. Click that there. So dark pixels are definitely not, there's nothing very other than vegetation. When we get down to 0, it should hopefully be equivalent to 0, then it's we're at the bottom end of what could possibly be classed as vegetation, and this is very strongly vegetation up here. So let's click on that, and yeah, it's the wrong way around, because of course it is. So we click on format color scheme, and we click on our two little triangles there, click on OK. That looks better. So this matches up a little bit better now with what we see here. So the bright reds are the greens in this, but it's a bit drab, and we don't really see much green in there. I mean, this is not this is a correct interpretation, but maybe we should change the stretch. Maybe we should change how the data is shown, stretched over the color scale. We've got values going between minus 0.89 something and 0.95, but perhaps actually we've got lots of values tucked away at one end and it's strongly biased towards that, or we've got a cluster in the middle, or we're just not seeing the details we want to see. We're not seeing what's interesting, what's relevant for us. So we need to redo that symbology, please. There we go. So that's the color scale that's being used, but how are we going to apply the data? Where are we going to put most focus here? So let's just change that to, we'll try it with standard deviation. That gives us a fairly good image. We get lots of strongly reflecting vegetation as being bright green, and then where we've got less vegetation, it's green but not as green. So this is matching up better with our idea of what happens. And we get these greys for the urban areas and this black then for the water. And these fields are also grey because there's no vegetation on them. Nothing's been growing there yet, which also now illustrates one of the weakness of NDVI. It shows us vegetation, and everything else just gets lumped together in a grey mass, as it were. Varying tones of grey mass, but it's still a grey mass. We can't really distinguish between what is a field and what is tarmac or concrete. But we can see different amounts of vegetation. So if we're interested in vegetation mapping, this is good. That's one way of doing it. We can use this map, then use this product to create a map indicating our NDVI. The alternative that we also should look at, this has just been using this nice function here, but what happens if we instead use something called a Raster Calculator? Now this is going to produce exactly the same result. So why are we doing this? Because the Raster Calculator is a good tool to become familiar with. It's fine to be able to click on a button called NDVI and get the result, but what if you don't want to do NDVI? What if you want to do something else? Then the Raster Calculator gives you a whole new way of accessing the data in these raster files, and you can do calculations with the different bands or with the file as a whole. So we can just recreate this NDVI here and have a look. So let's just go. So our first variable, let's call that band 1, and that's supposed to be this band 1 here. And so, well, if we click on that, we can't get it. So what we have to do is click there, and then we click on our infrared file, and we double click on it, and it opens it up into the 3 bands. Now we can get at them. So we can go band 1, click on OK, there it is. Band 2, type that in, and it's the same problem again. So let's just click there, and we want band 2. So now we have 2 variables, and I'm not quite sure why it didn't like that, but it likes it now. So let's look at the instructions and read what it says. I've done all that because we've got this slightly more complicated formulation to use, because the program, because this Raster Calculator actually, what it's going to do is it's going to take our integer values in these images that go from 0 to 255 in each band, and we're going to do this little calculation here, the B1 minus B2, band 1 minus band 2, and then divide it by the sum. And when we divide, we will almost inevitably end up with a fractional value, a floating point number. Now that is easy enough. Sounds easy enough, but the way this calculator works, and this is actually true in some programming languages, quite a lot of programming languages, that if you start with an integer and you divide by another integer, the result will be an integer. It will just automatically round the result to the nearest integer, 0 or 1, for example. So what we have to do is we have to initially take our values and say, turn these into floating point numbers, turn these into fractional values. So 0 becomes 0.000, 1 becomes 1.000, 2 becomes 2.000, 3 becomes 3.00, all the way up to 255, which becomes 255.0000. Obviously it takes up a lot more space, But there's no way around that. We have to do it. And this was done in the background in the other analysis, the automatic click of the button, it's done for you analysis. Let's just copy that. So what we're doing here, when we copy that in, is we're saying to it, take the data in band 1, which is integer values, and turn them into floats, floating point numbers. And do the same for band 2. And we're just repeating it there for the sake of fun, I suppose. And then we're going to then create a new layer using this method. So if we do that, create new layer, and we get our new layer there. This is the calculation. And when we look at these values, we can say, well, it's done exactly the same thing. What happens if we just go to the symbology and we say to it, we want that to be black and white, and we're going to edit it exactly the same way. We click on that, make that our leaf green, which is that one there. And then we want to add a stop in the middle that's going to be 10% grey. Good. And then we'll just flip those around immediately because we should. And then we also want to do, instead of percent clip, we'll do standard deviation. And it's the wrong way around because, what fun. Yeah, so we'll do that now. There's nothing like consistency in this. So there we go. And if we compare those two, they're exactly the same. So that's what it was doing. Whichever one of these you want to use, I really don't mind, but now you should create a map, a proper map, A4, showing the results. If you want to zoom in somewhat, don't zoom in too close, I want to see quite a bit of the map, but to be able to indicate some variation within the map, the different colours. We've got the water here, we've got the fields, we've got the tarmac and what have you, a variation in the background surfaces. If you want to zoom in a little bit, that's okay, but you will need to have in here, you will need to have in all the usual elements. Don't forget the attribution for the Swedish Land Survey and their data. They own the background data, you own the map, the product that you've created, but they own the background data. So what is that? How is that referred to? You can find that out quite easily by going to the folder here, documentation, and in here we've got references for how to, or instructions for how to reference them. So that needs to be in there. A nice title perhaps will be good. Scale bar, definitely. North arrow, yes. Coordinate grid, use measure grid rather than longitude and latitude. Use the measure grid to get SBG051, which is the coordinate system for these files. If we click on here and go to properties and we go to source, I believe, spatial reference there, and we can see it's SBG051. So that needs to be referenced, and your grid will show the coordinates in SBG051, measured grid. In the legend, the colours should be explained. Think about what it is that's actually being shown. It's the NDVI, which means what? How many decimal places do we really need? Because it will try to show you many decimal places. Like here, what does that mean? It's not terribly informative, so maybe you should consider rounding off a little bit somewhere so that it makes a little bit more sense. And then a text explaining what's happened, what this actually shows. And remember, what this does show is vegetation, some sort of measure of vegetation. It's relative, it's not absolute, it's only relative. The difference is important, and how we would do a more absolute examination, that comes in another course, in a more detailed remote sensing course. But for now, we can say that this is an adequate mapping of vegetation. And I think we'll end the video there.